Okay, so today we're going to talk about a special type of transformation known as a reflection. So a reflection is a transformation that flips everything over with respect to a line. Okay, so let's do an example. So let's say we have this over here. So let's say we have this 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. And let's say we want to reflect across, let me fix that really quick, across y-axis, or x equals 0. So here's our line x equals 0, right? So let's say we have the point A, which is 1, 1. We have the point B, which is 1, 4. We have the point C, which is 3, 4. Okay? We have our triangle, and we want to reflect across the y-axis. So however much distance we covered, going from the x equals 0 to A, we need to cover the same distance going the other way because we're reflecting across x equals 0. So it took a distance of 1, so the reflected point would be here. A prime is negative 1, 1. The y's do not change, right? And then here, this would be B prime, which is negative 1, 4. And then C prime would be negative 3, 4. All right, so that's how we do the reflection. And we got to write down our rule. I know I did, they should be the same triangle, bear with me. So from A, so it was 1, 2, A prime, which was negative 1, 1. B, which was 1, 4, and that moved over to B prime, which was negative 1, 4. And then C was 3, 4, and it moved over to C prime, which was negative 3, 4. So whenever we do reflections, we have to think which variable changes and which one doesn't. So we can see that the y doesn't change, right? Because 1 goes to 1, 4 goes to 4, and 4 goes to 4, right? But the x does change. So right off the bat, we need to do minus x when we're talking about reflections. And then we try to find a constant here to go in there that makes the rule work. But it doesn't look like we need a constant here. I think it's just negative x. Because 1 goes to negative 1, 1 goes to negative 1, and 3 goes to negative 3. So this would be our rule for a reflection across y-axis, or x equals 0. Let's do another one. So let's do another line. Let's do the same triangle. So 1, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. Let's do A, which is 1, 1. B, which is 1, 4. And C, which is 3, 4. And let's say we want to reflect across y equals negative 1. So let's figure out, let's plot y equals negative 1 right off the bat so we can see what we're dealing with. So this is y equals negative 1. So here's our points, our triangle. And we want to reflect across y equals negative 1. So same deal, but now the x's are going to stay and the y's are going to change. So 1, 2, 1, 2. So here we have A prime, the reflected one, is going to be negative 3. I'm sorry, 1, negative 3, right? So let me fix that. It's going to be 1, negative 3. B, so how much distance is covered? 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5, right? So here, and B prime is going to be 1 comma negative 6, right? And then C prime is going to be right here. C prime is going to be 3 comma negative 6, right? To get that reflection going. Okay, so let's try to find the rule, right? So A, 1, 1, and it moves to A prime, which is 1 comma negative 3. B is from 1, 4, and it goes all the way to B prime, which is 1 comma negative 6. And C, which is 3, 4, moves all the way to C prime, which is 3, negative 6. So obviously the x's stay the same. So we need a minus y. And I don't think just minus y is going to cut it here. Now we got to figure out that constant that we need. So what minus 1 gives me negative 3? Well, negative 2, right? Let's see if that works for the other ones. Negative 2 minus 4 gives me negative 6. Negative 2 minus 4 gives me negative 6. So this is our rule. X comma negative 2 minus y. Okay, let's do one more. Using the same triangle. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 7, 8, 9, 10. Let's see if that's enough. Okay, so I have my original triangle here. This is A, which is, let's do this. A, which is 1, 1. B is 1, 2, 3, 4. B is 1, 4. And C is 3, 4. Right, here's our triangle. And let's say we want to reflect it across x equals 4. So 1, 2, 3, 4. So we want to reflect it across x equals 4. So I need to fix this C a little bit, right? C is, let's see. This is C, and it's 3, 4. And it's right here. And we want to do a reflection, so same distance, but now the y stay the same. So 1, 1, we know that this is going to be C prime, which is, what will that be? 1, 2, 3, 4, 5. 5 and 5 and 4. Here it's going to be, let's see, 1, 2, 3, 1, 2, 3 for the A. So A prime is going to be, what is that? 1, 2, 3, 4, 5, 6, 7, 7, 1. And B prime is going to be right here. And that's going to be 7, 4. So here's our reflected triangle. Right? So let's get our rule. A, 1, 1 goes to A prime, which is 7, 1. B goes from 1, 4 to B prime, which is 7, 4. And C goes from 3, 4 to C prime, which is 5, 4. So what rule can we do? So we know the x's change, so minus x, and then the y stay the same. So what can we do? I think this is 8 minus x, right? Because 8 minus 1 is 7, 8 minus 1 is 7, 8 minus 3 is 5. Okay, so that's how you do all these types of reflection problems. You graphically, it's the same distance that is from the line to the figure or to the point, and then you just graph the triangle that reflects. All right, that's it.